Okay, this is the review on pulmonary ventilation. Remember that pulmonary ventilation means moving the air in and out of the lungs. Fresh air comes in, bringing in oxygen. Stale air moves out, carrying carbon dioxide. Now, air is a fluid. Gases and liquids are the two categories of fluids, and fluids always move from high pressure to low pressure. So what we have to do is control the pressure of the lungs to control the flow of air in and out. And the pressure of the lungs is controlled by controlling the volume of the lungs. So if you squeeze in on the lungs, then you lower the volume and you increase the pressure, and that causes air to flow out. Conversely, if you expand the rib cage and drop the diaphragm, then you expand the volume of the lungs, and that lowers the pressure in the lungs, and that allows you to inhale. Chemist named Boyle came up with this relationship between volume and pressure, that they are inversely related, meaning when one goes up, the other goes down. And so you need to remember Boyle's law. So we manipulate the volume of the thorax by contracting different skeletal muscles. The primary muscles of ventilation are the ones that allow you to inhale. They enlarge the thorax. The diaphragm, when it contracts, depresses its own central tendon, pushing down on the liver. The external intercostal muscles pull the ribs up, kind of like lifting the handle of a bucket. Each rib moves up. That expands the diameter of the thorax. All of that increases the volume of the thoracic cavity. To exhale, all you do is relax those muscles, and the elastic recoil will drop the ribs back down. The compression on the liver will reverse, and the liver will push back up against the diaphragm. These then act to decrease the volume of the thoracic cavity, which compresses the air in the lungs and increases the pressure and causes air to be expelled. There are other muscles of ventilation. We call them accessory muscles, or muscles for forced ventilation. The abdominal muscles, you can compress them, and that pushes up against the diaphragm. Other muscles that attach to the ribs, the internal intercostal muscles are the most important probably, but any muscle that attaches to the rib cage or even to the sternum can help with labored breathing, and labored breathing is called dyspnea. So we distinguish between costal breathing, which is usually very shallow, and diaphragmatic breathing, which is very deep. Okay, so the direct effect of the muscles is on the thoracic volume, and that changes the pressure in the pleural cavity, the pressure around the lungs. And as this pressure changes, then it pulls either pulls out on the lungs or pushes in on the lungs. So when you're inhaling, you pull out on the lungs. This increases the lung volume, which drops the lung pressure, which lets you inhale. Or if you're pushing back against them, then the pleural pressure increases. That compresses the lungs. That makes the lung volume smaller. That compresses the air in the lungs, and that allows you to exhale. You need to know the normal value. Normal atmospheric pressure at sea level is 760 millimeters of mercury. But this changes with altitude. The higher your altitude, the less air you have over your head. And even though air is floating, it's still kind of compressing whatever air is below it. So air pressure is lowest at sea level. And then, of course, if you go diving in the water, water pressure is higher than air pressure, and that compresses the lungs even more. Because differences in altitude are going to affect what the atmospheric pressure is, we just say, okay, air pressure, wherever you are, that pressure is 0, and we're just going to compare the lung pressure to whatever the room air pressure is around you. So generally speaking, the pressure in the lungs is only going to change by about 1 to 2 millimeters of mercury, maybe up to 3. So if you're going to inhale, you enlarge the lungs, the pressure only drops. Say if it was at 760, then it's going to drop to 757. We would say that's -3. And then when you compress the lungs to exhale, the pressure might go up to 762, which is a difference in pressure of 2 millimeters mercury. So we just compare it to if 760 is 0, then 763 would be positive 3. When you measure respiratory volumes and capacities, you're measuring how much air the lung either can move or the amount of air that's being held in the lungs. You need to know the normal ranges for these. You need to know the abbreviations. You need to know the terms. Tidal volume is the amount of air inhaled or exhaled. We usually measure this as a resting tidal volume. For a small female, it might be around 300 milliliters. For an average size male, around 500 milliliters. The expiratory reserve volume is the amount of air left in the lungs. If you have exhaled your tidal volume already, how much more could you exhale? It's around 1 liter. Inspiratory reserve volume of around 3 liters is the amount that you can inhale if you've already inhaled your tidal volume. In other words, inhale normally, and then how much more can you inhale after that? The residual volume is the amount of air left in the lungs even if you've exhaled as hard as you can. You never completely deflate the lungs. So usually this is around the same as the expiratory reserve volume, but it does increase with age. It increases with diseases such as emphysema, because as lungs lose elasticity, you can't recoil them as well. So more and more air gets trapped in the lungs as you get older. This is also the basis of the determination of death of a newborn. If a newborn is found after death and they're trying to determine whether it was stillborn or not, if that infant took even 1 breath, then there will be some air in the lungs. And if it was stillborn, there will be no air in the lungs. And so on autopsy, you can determine that. Now, the volumes are all kind of separate. They're not really physical partitions, but you can think of them as separate categories of breaths that don't overlap. The capacities are combinations of the volume. So your inspiratory capacity is your tidal volume plus your inspiratory reserve volume. Your functional residual capacity is your expiratory reserve plus your residual volume. Vital capacity is pretty important because it's the one that is a measure of how much you can breathe. It's all of your breathable volumes, everything except your residual volume. And total lung capacity would be all 4 volumes added together. So you can figure out that a normal total lung capacity would be about ½ liter plus 1 liter plus 3 liters, that's 4. Another liter for residual would be 5, so 5½ liters would be typical total lung capacity. If you want to measure how many breaths per minute, then you can measure your ventilatory rate just by multiplying the number of breaths you take, and a normal value for that is 12 to 24 breaths per minute times your tidal volume if you're breathing at rest. If you want to take into effect how much air stays in the dead space of the lungs, that is the conducting zone, that's about 150 milliliters. So if you want to calculate the alveolar ventilation rate, how much of the air actually gets down into the alveoli, you would subtract the 150 mils for the dead air space from the 500 milliliters of your tidal volume and multiply that by your respiratory rate. Okay, that's a quick overview of pulmonary ventilation.